Ahoy, Glenwood Springs! It be Cartbeard, the mathematician pirates, here to navigate you through these rough online waters. This yar, more than any other yar, has been especially important that we stick together as a crew. Means any proceeds, any profits, as of right now there are zero. But any financial gain made by this YouTube channel will be split amongst our class. The plunder will be many, the booty will be shared amongst us evenly. And this is my solemn promise to my crew as we go through this rough time together. And you have to bear witness to all these horrible YouTube videos and learn math at the same time. We will be in this together. Thank you very much. And now to return home so I can prepare for math class.
What is up, Glenwood Middle School? Welcome to fabulous day 15 of your online math curriculum. I'm super excited to be here, and I hope you guys are as well. You can tell that I really learned how to draw trees well from our Monday activity. And I also want to hear your thoughts on whether or not you guys like green in the background or yellow as the color of choice. What we are talking about today is what we've been talking about so far in Unit 2. Which is dilations, right? And dilations are making something bigger or smaller. You can do it either direction. So a dilation going this direction would be smaller, dilation going the other direction would be bigger. All I did was I took the same triangle and I expanded it or contracted it. What's important to note in dilations is that it creates a similar object. Similar means all angles are the same, right? All angles are congruent, all angles are equal, and it is the same shape. So you have the same number of angles, same position, same type, but the distances in between those angles is changed. So that's what changes in a dilation, is the overall size. Think of it as zooming in or zooming out. So yeah, dilations, different sizes of the same object. They will create similar objects, right? Not congruent objects. So now we have to figure out what the scale factor is, right? And so let's say I have a triangle and he has a side length of 3. And we're going to dilate this triangle and we're going to make him bigger this time. And let's say we are going to use a scale factor of 4. So we want to make that triangle 4 times bigger. I'm going to go and draw it. 4 times bigger of a triangle, right? Bigger triangle. That's a dilation of a factor of 4. So what does that mean on our triangle? It means that this value of 3 should be 4 times bigger on its corresponding side. So you can see how the sides are matched up. Those are corresponding sides. And 3 times our scale factor of 4 would give us the new length of the triangle side. So 3, 4 times bigger is 12. I'm going to give you another side length and have you do it. So if the side length is 5 and we dilate it by a scale factor of 4, what would the new side length be? Very good. Congratulations. It would be 20. 5 times 4 is 20, and that is the bigger triangle, right? We can also go the other direction, and we can make things smaller using a scale factor. So let's make a square this time. And that's not a very good square, but let's make them a little bit bigger. And let's say that each side of this is 10, okay? We can make something smaller by using a scale factor of less than 1. So if you notice that when we made it bigger, 4 was bigger than the number 1. So this shape got bigger. However, if we use a fraction or a decimal for a scale factor, we will make it smaller. So if we use the scale factor of 1/2, we are going to make a smaller square. And I'll give you guys a second to try to figure out what the length of a side length is for 1/2. Very good. We take 10 and we multiply it by the scale factor of 1/2 to get 5. So what you're going to do in this unit is use your scale factor to multiply the corresponding side lengths. Once again, these side lengths match up, right? They're in the same position. And you're going to use that to determine any new side length. So we took our scale factor, we multiplied it by our original to get our new smaller shape. All right. The other thing we're going to have to learn how to do is finding a scale factor. So if we are given two shapes that are similar, so let's make a circle, radius of 3, and a circle that's bigger with a radius of 9. So if we have two circles with different radiuses, how do we determine the scale factor? And so what's cool to note about circles is that every single circle is similar to every other single circle on the planet. By definition, they have the same angles, right? They're all 360 degrees. So all circles are similar to each other. But how do we find the scale factor? How we would find the scale factor is we put the image over the original. So if our original circle was 3, we would take the image's value and put it over 3. So in this case, our scale factor would be I over O, the image over the original, and in this case it would be 9 divided by 3, which gives us a scale factor of times 3. So in this case, the scale factor is 3. So what you're going to do on scale factor, if you do not know what it is you're going to take the original object, you're going to put that on the bottom of your fraction, and you're going to take the new object, the object you created after the scale factor, you're going to put that length on the top of your fraction. Same works for triangles, squares, or any shape you can think of. And let's just do one more just to be sure we got it. So I will give you guys actually, I have this on the next page. So it's your turn. What is the scale factor between these two shapes? I have a square that is a 15 by 15 and a square that is a 5 by 5. We are going to say that this is shape 1, or our original image, and this is shape 2, or what happens after the dilation. So I'll give you guys 30 seconds to figure that out, trying to determine what the scale factor is between the first one and the second one. Very good. What you would do is you take one side length from our first image and our original image, and that goes on the bottom of the fraction. And you take one side length from our image or our dilated figure, and that goes on top. So our scale factor in this case is 5/15, which can reduce down to 1/3. How I reduce a fraction is I'm looking for the greatest common factor of both of these numbers. In this case, the greatest common factor is 5. 5 goes into 5, and 5 goes into 15. So I can divide both the top and the bottom by 5 to get 1/3. Usually on tests, Mr. Cartwright will accept non-reduced answers. However, on multiple choice questions, it will almost always be the reduced answer. So if your answer is not in the multiple choice, try reducing it. Thank you guys so much for paying attention. Have a wonderful day, and please return to the live classroom. Thank you very much.